Today is Pi Day, 14th of March, which is 3.14, which is pi. And today I have selected a complicated math to you. Actually not that complicated, but very interesting. You learn this in applied math in Hong Kong. And that's called Newton's method. Now before talking about this, I would like to write down the general formula of it. X sub n plus 1 is equal to x sub n minus f of x plus n divided by f prime of x sub n. This is the general formula. It is used for solving some equations, any kind of equations. Let's say we want to solve a quadratic equation, x squared minus x minus 1 equals to 0. Indeed, this has two solutions, but Newton's method can only find one of them. Okay, let's start. The first thing we need to do is let f of x be x squared minus x minus 1 be the left hand side. And then the second thing we need to do is to differentiate the whole equation, which is f prime of x, because we need to know f prime of x in order to use Newton's method. And then we differentiate x squared, we get 2x. We differentiate negative x, we get negative 1. We differentiate a constant, we get 0. So now we are done finding both f of x and f prime of x. Okay, the third step we need to do is to find some value of f of x. Perhaps I like 1 and 2. We will need to find both f of 1 and f of 2. Now we substitute x to 1 and 2. We get 1 squared is 1 minus 1 is 0 minus 1 is negative 1. 2 squared is 4 minus 2 is 2 minus 1 is 1. And then we pick a number between these two answers. Perhaps I like 0.7. And then the fourth step, we will say x sub 1 equals to 0.7, the number we picked. Now this is at some point close to the solution, right? But every time we find a new value by this formula, it will be closer to the solution. So our second iteration will be the previous one minus f of the previous one over f prime of the previous one. So now we're substituting 0.7 into both equations. I write down here first 0.7 minus f of 0.7, which is 0.7 squared minus 0.7 minus 1 over f prime of 0.7 to 0.7 minus 1. And now let's use a calculator. 0.7 minus 0.7 squared minus 0.7 minus 1 divided by 2 multiply 0.7 minus 1, and we get 3.725. Now this is at some point close to the solution, right? But every time we iterate this pattern, we will get more accurate answers. And this is why Newton's method is interesting. So now we will want to find x sub 3, which is 3 the previous one minus f of the previous one over f prime of the previous one. Now the calculator automatically stores this answer to the variable answer, so we can directly use the answer button to replace this 3.725. So now we just input answer minus answer square minus answer minus 1, because that's our f of x. That's our f of x. And then divided by f prime of x, 2 answer minus 1. And then we get 2.306 approximately. And then we don't need to input again. We just press CSC. This answer is now covering this answer, so it will keep on iterating. So our x sub 4 will be 1.749. X sub 5 will be 1.625. And then x sub 6, 1.618. Now, no matter how many times we keep on iterating, it stays the same. After, at some point, the solution keep on staying the same value, this will be the solution. Let us try another one. Let's say 100x squared plus 19x plus 4 is equal to 0. We use large number so that you can see that Newton's method works for any kind of equation. So it is powerful. Perhaps you don't remember how to solve an equation, you can always use Newton's method. Although it is take a quite long time, but it's still worth it. Okay, so the first step will be letting f of x equals to this guy up here, and then we will want to differentiate the whole equation. We get f prime of x. We differentiate 100x squared, we get 200x. We differentiate this, we get 98. And then we differentiate a constant, we get 0. So after we get both answer, we will want to try some value of f of x. Perhaps this time I want 0 and 1. So now we substitute 0 in it and 1. It equals to 0 plus 0 plus 4, which is 4. 100 plus 98 plus 4, 202. Now the range is quite big, but we can still pick a number between them. Perhaps I like 7. Any number will work between this range. Now x sub 1 is 7. Do you agree with me this is at some point close to the solution? Yes. But every time we use Newton's formula, we'll get a closer answer. So let us refer back to this formula. We get x sub 2 equals to the previous one minus f of the previous one over f prime of previous one. Now we will store 7 to the variable answer, so that we get answer is equal to 7, so that we can directly input answer minus f of 7. Our f of x is here. Our 100 answer square plus 98 answer plus 4 divided by f prime of x is 200 answer plus 98, and then we get 3.627 approximately. And then we press CSC, it will iterate itself, we don't need to input again. We get 1.41, we get 0.51, 0.11. It keeps decreasing. We need to wait it stay the same. and then press again, negative 0.04, and then it stay here. So our final answer will be negative 0.0427. All in all, Newton's method is not useful because we already have some way to solve any kind of equation. But perhaps one day your friend asks you to solve that quadratic equation for him, and then you don't use the quadratic formula, you use Newton's method, and this will surely give a surprise to him. Thanks for watching. Happy Pi Day. I hope you understand Newton's method.